In this video, we're going to be covering section 1.2, part 3. It's going to be a fairly short one. Today, we're just going to be talking about functions and determining whether a relation is a function or isn't a function, and how we can tell the difference both by doing it algebraically and by doing it graphically. All right, so in this video, we're just going to go over one example. There are going to be 3 parts. So as we look at part A, we have a relation between x and y, but the question then becomes, is it a function? And I think right away, most of us are going to know the answer to these without really doing much. The question is, can we justify it? So for part A, let's go ahead and take a look at this and do this graphically first. So I need some graph paper. All right. The hope is that you recognize this equation, you recognize what graph it makes. But if you don't, then we can always rely on our table of values. This is in the family of things called a conic section, and some of you in this class may or may not have covered conic sections. And if we just start plugging in x values and solve for y values, we can kind of quickly get that answer. So I will do that very quickly. If you need to skip ahead 15 seconds, 30 seconds, just to move forward, that is fine if you already know how to graph this. So if I make a t-table, I make x 0, then we're simply left with y squared equals 9. And when I take the square root of that, I'm going to get both 3 and negative 3. And so at 0, I've got 1, 2, 3, 1, 2, negative 3. And as I plug in different values, I'm going to get like so. I don't want to do 1. I don't want to do 2, 3, 4. 5 looks, no, not 5. What am I talking about? Actually, the values are going to get pretty tough here. I'm going to go out to 3 and plug that in. And if I plug in 3, I get y squared equals 0. And so the answer is 0. So 1, 2, 3. And if I plug in negative 3, I square that, I get 9. That's going to lead me to 0 also. And so what I have is this shape right here. And to get the details of the inside, we would need to plug in some more values. And what we're going to find is it's not a straight line. It doesn't make like a rhombus. This is what's known as a circle. So a squared plus b squared equals r squared is the equation for a circle centered at 0, 0. So a squared plus b squared equals r squared. Or actually, that was silly. Sorry, it's actually about 4:30 in the morning right now, and my brain is just waking up. X squared plus y squared equals r squared. That is the equation of a circle with a radius of r centered at 0, 0. And we will review this later in the year for those of you who have not had conic sections. Okay, so clearly by looking at the graph, it fails the vertical line test. If we pass a vertical line over this, we're going to hit, at any point, we're going to hit multiple values of y for one single input of x. And so I would answer this question, determine whether it's a function graphically. I would say this is not a function because, I could have used the because symbol. It fails and I'm going to abbreviate the VLT, the vertical line test. All right. But now let's do it algebraically. So algebraically, the other way we could have attacked this problem, instead of plugging in for x right here, right? We could have solved for y. So let's instead take this equation and let's rearrange it to get it so it says y equals, which is how most functions we know come in. So I'm going to subtract x squared. And now I need to take the square root. And the rule is, if you are the one that's introducing a square root to solve a problem, right? as opposed to running into a problem that already has a square root in it, right? So compare what we just did to answering the question, you know, if I just ran across this, right? So somebody said, hey, what does this look like? They didn't put plus or minus, so we always interpret that to mean just the positive root. So anytime you run across a square root out in the wild, it's already there. You didn't put it there. You didn't introduce it into the problem. You are trusting whoever created that to be telling you that they only want what they've written down, which is the positive root. However, in our case, in order to solve this equation to get y by itself, we had to introduce a square root, right? We had to take the square root of the left side and the square of the right side. So we're the one that brought the square root to the party. So that means we need the answer to the positive and the negative. Because without it, we haven't fully answered the question of what y values would be, right? We need the positive and the negative. And that in itself is the answer we have. So because we have the positive and negative, that means for each input, we're going to get two values, the positive and the negative. So the answer, we would show this work, and then we might say something like, again, this is not a function because each input, and maybe be specific, right, between -3 and 3 leads to two answers. Something like that. I'm not saying it has to be word for word what I've done, but again, what I'm trying to model for you is if you're asked a question, answer the question, right? So, is it a function? The answer would be no, this is not a function. Well, why isn't it a function? Because of these reasons. Okay. Don't just say no and point at your work. You need to answer the question. Okay. All right. So, this next one, solve this graphically, see if it's a function. And really, the answer lies in the algebra of it, because in order to graph this one, it doesn't instantly jump out at me. I'm a little worried it's a sideways parabola because of the x squared there sitting over at the y. But if I just I'll do the algebra of it first, I guess, because in order to graph it, I would make this say y equals. So I would move the x squared over, and I would multiply by -1. And now I know what this looks like. This is a parabola down at 1, 2, -3 with our standard parabola graph, up 1, up 3, up 5 if I want to keep going, which I do not. And so I would say, yes, it is a function because it passes the vertical line test. And algebraically, I've already kind of done the work. And so I would say basically, yes, it is a function because for each input, there's only one output. Okay, sounds good. Looking back and thinking about justifying number one, you might want to say because each input between -3 has two answers, and you might even say, because of the, the positive and negative of it. Anyway, just to be fully answered. All right, let's take a look at this one. First glance, I got no idea. I'm thinking rational function. Rational functions do pass the vertical line test, so I'm initially thinking that. But then I'm noticing the two y's there, and I'm like, I don't really know. Like, I look at this, and my first gut instinct is to say, I don't know what this looks like. So when faced with that question in math, a good math student will do one thing that a bad math student will not do, and that is they'll just try something. And that's what I expect out of you in this class. You don't know what to do, don't throw your hands up, don't ask for help immediately. Just try something. So I'm looking at this problem and deciding what to try, and honestly it goes to, well, I think the problem would be easier if I didn't have a fraction in it. And so why don't I try to get rid of the fraction? So I think I'm going to multiply both sides of this equation by y. And so that's going to give me xy on the left side and equals 3 minus y on the right side. Okay, still don't love it. If I want to get x by itself, I would just go in a circle back to where I started. If I want to get y by itself, I guess I need to add this y to the other side. So I'll do that. I get y plus xy equals 3. Y plus xy can't add together. So I've seen students at this point say, I don't know what else to do. I don't know what this is. But I'll remind you that we can add those y's together. It just looks a little weird. It's actually going to look like factoring. I can add a 1y plus an xy by factoring out the y. So if I factor out y, I'm left with 1 plus x equals 3. And then if I divide by 1 plus x, I get y equals 3 over 1 plus x. Or x, you know what? X plus 1. All right, so now I think I know my answer. And if I graph this, I'm not going to make a table of values, but if you need to, please do. This is a rational function. I know that it has, essentially, it's this function, right? It is essentially f of x equals 3 times 1 over x plus 1. And so what do I know about this graph? I know it's shifted into the -1. It has not shifted up or down because there's not a plus on the outside adding it up or down. And so we have an asymptote also at the origin here, or on the axis, I mean. And so normally I would come over here and say I have a point at 1, 1, but now that's going to be 3 times as tall. So my point's actually going to be 1 over and up 3. And if I go over 3, 1, 2, 3, it's going to be at 1. And the same thing's going to happen here. I'm going to be at 3 and 3. And so this turn is going to be a little wider than usual. And again, we're going to review all of this when we get to this section. And so I get this graph. And so the answer again is yes, it is a function. Because it passes the vertical line test. Algebraically, well, I made it say y equals, and in doing so, I didn't create a situation where I have a positive negative. I didn't take a square root. I don't have any other weird conditions. This is just a rational function. So I would answer it the same way, really, as I did the last one. I would show the algebra to get to here, and then I would say, yes, it is a function because for each input, there's only one output. Okay? So that's all this is about today. It's not about the answer yes or no. It's kind of more about the justification and fully answering the question. All right, that's it for this video. If you have questions, we'll see you in class.